The Webb looks so far out that it's capturing light that's been traveling for over 13 billion years. But the universe has been expanding, and so the light has been stretching. For the most distant galaxies, we're looking back in time almost to the Big Bang. Everything we thought we knew about the beginning of the universe may be wrong. Recent discoveries from the James Webb Space Telescope suggest that our understanding of the oldest galaxies, and even the Big Bang itself, might need a major overhaul. In 2022, a deep field image from the telescope shocked the scientific world. Reddish specks of light and distant galaxies didn't fit into the previous picture of the early universe. Hundreds of these unexplained galaxies are shaking up what we call the Dark Ages. Could we be on the brink of a scientific revolution, as suggested by the famous British physicist Brian Cox? Let's find out. Maisie's galaxy, one of these new and very old galaxies, was discovered by astronomer Stephen Finland of Austin, Texas. He named it Maisie's galaxy because he made the discovery on his daughter Maisie's birthday. Initially, they thought the galaxy formed almost immediately after the Big Bang. Initial measurements revealed an incredible age of more than 13.5 billion years. They estimated it existed only 290 million years after the Big Bang. After a more detailed analysis, they determined it was another 100 million years older than first thought. Maisie's galaxy was officially declared the oldest observed galaxy, but the new record holder couldn't hold its rank for long. Currently, about 10 other galaxies are being evaluated that could be even older than Maisie's galaxy. If findings of galaxies existing even closer to the Big Bang are confirmed, we can only imagine what will happen. The gap between the Big Bang and the formation of the first stars and star systems gets smaller with each new discovery by the James Webb Space Telescope. And that's not the only thing the telescope has discovered in just a year since its launch. Recently, it found a type of star only suspected to exist. James Webb, sometimes jokingly called the mighty eye of NASA, is well on its way to forever changing our perception of the cosmos. The JWST has discovered 3 candidate dark stars that were previously only a theory. Dark stars are powered by dark matter, and although it sounds paradoxical, these stars can shine brighter than any other stars. Over time, dark matter, believed to make up most of the material universe, cannot be seen with conventional telescopes. The only way to map its presence is through gravitational effects or, more simply, the weight with which it stretches space-time. Dark matter is invisible and does not emit light, yet it possesses a strangely large weight. This weight causes complex interactions to occur in space. In the case of dark stars, the weight of invisible mass can initiate processes that produce light, just as the mass of a dust disk rotating ever faster will eventually become so compacted under its gravity that a nuclear fusion process will be initiated. Normal stars, like our Sun, are driven by normal matter. Dust and gases collide, swirl around, and speed makes them denser and heavier. Dark stars, however, are powered by dark matter particles. This discovery is exciting and could be a portal to answers we've long sought. If dark stars exist, they could be the key to understanding the light-generating processes in the universe. For about 15 years, scientists have speculated that dark stars were among the first stars our universe formed. Scientists initially estimated the timing of the first stellar evolution to be 700 million years after the Big Bang. Now, entire galaxies are appearing that existed 300 million years after the Big Bang. The riddle of dark stars, if proven true, may help us understand how galaxies could have existed so early in the cosmos. In the case of dark stars, Webb's observations indicate that 3 distant objects fulfill all the key characteristics of dark stars. They are luminous but too cool for fusion. The 3 candidates for dark stars are JGSC 13-20, Z120, and Z11D0. These 3 luminous objects would thus not be galaxies, but possibly mysterious dark stars. To clarify parameters in determining dark stars, researchers seek changes in light intensity. Predictions of dark stars yield specific frequency band values. Researchers now analyze the light signatures of 3 objects, looking for indicative frequency bands. Despite advanced technology, this measuring method is uncertain, making definitive statements challenging for distant objects. Exploring phenomena at the cosmos's temporal edge is like a guessing game. Scientists rely on known values and basic physical rules, acknowledging numerous unknowns. The JWST introduces a new challenge, questioning standard models due to the abundance of early, massive, and bright galaxies. This discovery might reveal the true age of our universe, challenging established scientific theories. Professor Rendragupta's theory, a physicist at the University of Ottawa, could gain global recognition if proven true. Gupta's innovative approaches aim to explain the JWST's puzzling discoveries. The mystery of the impossible early galaxy could be solved by roughly doubling the age of the universe. Gupta didn't just shift the time of the Big Bang. His theory has merit based on two modifications of previous assumptions. Scientists initially estimated the universe's age by measuring the time since the Big Bang. The second clue involved studies on the properties and behavior of the oldest objects in the cosmos. Until Hubble's advent, while parameters were somewhat correct, questions lingered, and no universe breakers, like impossible galaxies or massive stars, appeared. To determine the age of distant objects, researchers use redshift, where light undergoes stretching as it travels, shifting the spectrum into the red region. The farther an object, the older it is, and more redshift waves appear. Initially, an estimate suggested our universe was about 13.79 billion years old. Gupta's work addresses an error in redshift, drawing from Fritz Zwicky's 1920s theory of tired light. This theory posits that redshift isn't only due to galaxies moving away, but also because light loses energy as it travels, potentially making the assumption of an expanding universe false or producing inaccurate measurements. Paul Dirac, a physicist from the last century, proposed an intriguing and relatively unnoticed thesis. His research focused on coupling constants governing basic rules for particle motion and interactions. Dirac suggested these constants might have changed over time, implying that particles behaved differently in the early cosmos than they do today. This concept could potentially explain the advanced evolution of the galaxies observed by Webb, and why previous assumptions about the cosmos have fallen short in providing conclusive explanations. The current question is whether scientists can formulate new universally valid models and theories based on recent observations. We may be on the verge of a scientific divergence until unequivocal evidence emerges. This evidence might come in the form of sightings of galaxies even older than those in James Webb's first deep field image. Although the telescope's estimated range is 13.5 billion years, advancements in technology or the discovery of new details in light frequencies could push our understanding further. This situation poses a significant challenge. Scientists cannot cling to old theories when the cosmos reveals something different. Fundamental questions about dark matter, dark energy, the movement and potential end of our cosmos, and the existence of a beginning remain unanswered. The idea of living in an infinite universe without a defined beginning or end must be considered. Despite the coherence of the standard cosmological model and the Big Bang concept, questions persist about the first moments after the Big Bang and the origins of elementary particles and atoms. The quest for answers to these cosmic mysteries emphasizes the importance of challenging existing paradigms. Scientists grapple with the realization that the universe may be more intricate and dynamic than previously thought. As the pursuit of knowledge persists, the search for evidence extends beyond the limits of current understanding. Exploration into the nature of dark matter and dark energy represents a frontier where breakthroughs could reshape our comprehension of the cosmos. The movement and potential fate of our universe remain elusive, prompting scientists to question conventional narratives. The concept of an infinite universe without a discernible beginning or end introduces a profound shift in perspective. Uncertainties surrounding the first fractions of a second after the Big Bang and the origins of elementary particles and atoms highlight gaps in our cosmic narrative. The standard model of cosmology, while providing a framework, leaves crucial aspects unanswered. Acknowledging these gaps fosters openness to new possibilities and encourages a reevaluation of our cosmic understanding. In this era of exploration and technological advancement, the cosmos unveils its secrets through the lenses of powerful telescopes and innovative instruments. The scientific community stands at the precipice of discovery, ready to embrace the challenges posed by the cosmos and unveil the yet unknown chapters of our cosmic history. If you enjoyed watching today's video, be sure to leave a like and a comment. Also, Hit the subscribe button to watch more exciting videos like this.